Good morning and welcome. Today I want to cover a topic not always well known in the circuit breaker industry. So our power topic for today, power engineering topic for today, is what are these symbols, ICU, ICS, ICW, ICM? What are these indicators as we see on circuit breakers? So on all circuit breakers, you are going to see an indication of the KA of the device. It is a legal requirement to have that on the device, and it's normally displayed as ICU equals, in this case, I've got an example of 20 KA. This is the ultimate breaking capacity of the breaker. That means this is the breaker that would withstand 2 operations at that level. If we take a fuse, you will only withstand 1 at the KA, and then you've got to replace the fuse. A circuit breaker obviously gives you some advantages here. You will break a circuit at that level. You will then close that circuit, be able to close that circuit breaker afterwards, and it will trip again. Beyond that, the breaker is technically beyond its life. It's at end of life. It will do this and it will accomplish this without danger to the operator. In other words, the breaker itself is going to withstand things, and it's going to do certain tests as prescribed in the qualification of that in terms of IEC, SANS, or one of these specifications around the world. But it's not going to be a comfortable baby thereafter. It's going to have a heat rise beyond the norm that it's there. It is in not a good condition. To have a short circuit at this level is not something that's going to live forever with a circuit breaker. It's not a miracle device. It is going to require replacement very shortly thereafter. So we need to understand that if we get levels in that level of short circuit, it is a full-on life-defeating damage to that circuit breaker. On a lot of other devices, there is an ICS indication. Now, sometimes in today's modern world, you see ICS equal ICU, which is the top industry rating value for an ICS. And really that means that that breaker has been tested not twice, but 3 times to the short circuit. In other words, the life of this type of indicator is a lot higher. It's 1 more operation based on that. It does not necessarily have to be equal to, but the argument could be made that a circuit breaker that is equal to is better than one which is not equal. Very difficult to always prove that in the real world, because a circuit breaker does not always trip at this level, and generally trips at a much, much lower short circuit level. And obviously within that, typically an example would be 6 times rated current short circuit tripping may give a life on a product between 25 and 50 operations. So when you have a lower than established maximum short level circuit, you get far more life out of it. But in the past, having a percentage value, if it was ICS equal 50% of that, was an accepted norm. There's no legal specification to have it spec'd at 100% or equal to. And that's generally the client or the specifier's task to decide whether they would like it at that level. We also have something called ICM, and we can always have a look at the values. This is a rated making capacity. So this is not generally on circuit breakers, because they can make up to their, normally if you just have that on there, but a making type of thing you often see more on contactors, because you can't close a contactor, for instance, into a short circuit. You will damage the contacts. And the same with any device which is actually moving and closing. These are normally circuit breakers and isolators, generally on load switching. In other words, they can switch at rated values consistently without damage. You do get isolators in the world, generally on the high voltage side of it, where you cannot close those isolators into a short circuit. You will damage them, and if you're standing close by, you will be seriously damaged yourself. injury if you try and do that. Generally speaking, in our low voltage side of life, all the isolators are on load type capable. So in other words, you can close them straight into a short circuit and expect that to survive that event. If it was not so, it would have massive ramifications in the electrical industry. We would have problems going and closing a switch or an isolator into a potential short circuit, and the breaker doesn't see the trip, and the device you just closed, it would explode in your face. That's something we don't allow in the industry really, because the isolators and the breakers are kind of at the same level. We also sometimes see ICW. It's a withstand type of thing, and this is in fact coupled very definitely to your isolators or switches, and it must be normally qualified. In other words, if it says 20 Ka, and it must say that in terms of milliseconds or seconds or withstands. And the idea behind this is that if you did close this isolator into a short circuit, it must be able to withstand that short circuit as long as it takes for the upstream breaker to see the fault, clear the fault, and rapidly do it. It's no point having an isolator you can close in which gets damaged before the breaker upstream is allowed to trip. Now, traditionally in the electrical game, some manufacturers might say, this is a product, it's an isolator, it's a switch in a breaker, in a panel board, related to the family of breakers in that size. In other words, there's an equal type or similar isolator to that, might say 40 milliseconds, which means it allows 2 cycles to go through before there's any damage, or it's been tested to that there is no damage in 2 cycles. And traditionally, your circuit breaker will require really only 1 cycle to trip, and so therefore it would survive. 1 in 3 seconds is often coupled to the length of short circuits, which could be apparent in an electrical network, and this is often applied and seen more in the actual busbar level, so it can withstand a serious short circuit for something like 1 or 3 seconds. An isolator might be also spec'd at 1 or 3 seconds, but its Ka is going to be nowhere near spec'd. So it's not going to be 35 Ka for 3 seconds or 1 second in an isolator used in a panel, which is, say, a 30 Ka breaker, and that isolator is a family isolator to those breakers. So it's very difficult to actually see that. It's in no way related at all to the Ka on the system Ka. So you don't need, if you see an isolator specified by a manufacturer as 8 Ka for 1 second or 8 Ka for 3 seconds, you can still apply that at 35 Ka if the product range comes from that family. So it's always related to that. Don't use and think of the isolator as a separate being. It's always in the network of things with the circuit breakers. So ICW is very often there. It's there simply that the circuit breaker is allowed to trip upstream, should that be the event that has just occurred. I'm open to some sort of questions on this. I know it's a bit short, and we may not have covered all the topics in it. If you pass your comments on to the YouTube channel, I'll get back to you as fast as I can.